Hey everybody, it's Dark Guardsman. We're back with another video. Now we're going to continue where we kind of left off, and we're going to be talking about the radiation more. So since the last time, I went ahead and got the radiation system actually fully implemented now. So no longer are we just kind of theoretically doing things and theoretically calculating values. We actually have some playable content here that we can sort of see. It's a little hard to see the effect of it because it's not something that is present in a way that you're going to notice physically, but it is something that is going to affect gameplay. Now, for those who haven't been following the last few episodes, I've been working on a radiation system in order to track the amount of radiation you will be exposed to per location. This is being done by storing a radioactive material per block, and we don't actually have to make our own blocks to do this, even though I do actually have a radioactive block that we will be using that's entirely decoration, and will change to kind of indicate how much radiation is in location, just to give you a visual update type system. But the core gameplay component will be that every block can be radioactive, every entity and every item can be radioactive, so when you end up setting off some kind of thing that would spread radiation, it's going to spread on everything and make cleanup really, really hard. But part of this is also going to be that we're actually going to have a data set that will update and will do things. So we have one data set that's going to be track the amount of material. And this is going to be tracked in an arbitrary value, meaning it has no real world connection. I thought about doing this in grams, but at the moment it doesn't really make sense because, one, I don't know how much would be spread around, so if I'm using realistic values for something that I don't quite understand, I'm not going to get the gameplay I'm looking for, so we're going to use an arbitrary value for this one. We are going to use realistic values for the amount of radiation actually transmitted from certain things, so once we take this arbitrary value, it's going to be converted into a value that will work realistically, so will be turned into something that is similar to the amount of grams of radiation or radioactive material you will have, which will then be turned into radiation. How this radiation actually will work, and we're going to use this as a reference point, is that we would have a radioactive block here, and it will spread out and actually start spreading radiation everywhere. Now, radiation is not an actual physical object. It's basically the same as light. It spreads out in all directions, and when it hits you, it transfers energy in your body and actually damages your body. Now, if you can already tell, I have this little display at the top that shows me rims and rads. Now, the difference between these two is that rims is how much radiation your character is actually absorbed, and it's relative, it's retrogen equivalent to human or something. It's really weird to say, but effectively it's the amount of radiation that would be equivalent to your body and the amount absorbed. So now, not every creature on the planet, not every part of your body absorbs the same amount of radiation. So they have this relative measurement that goes, okay, if you get hit by an alpha particle, a beta particle, you get hit by X-rays, gamma rays, you're going to take this amount of damage effectively. That's how they do it mathematically in real life, and I've got the mod reflected in the same way. Because certain types of items are going to transmit certain types of radiation, and that radiation is going to affect you in different ways. In this case, we're going to just store it as rims, and then the environment tracker is going to be in rads. Even though technically both of the values are identical, because whatever the rad value you do see is going to be the value absorbed. This is just for simplicity of gameplay, because after all, if I make a data storage set where we're actually storing the radioactive material, I don't want to be storing the exact type of material, so I'm just going to go ahead and transfer that type of material into a relative value, store the relative value, and then just do that way. Gameplay, it'll be exactly the same as if I stored it individually, and will work out. Now, to actually show this off working, let's get rid of our placeholder, and let me stand right here, and I'm going to run a command here. Now, I do have commands for this, and let me actually type in the right command. I don't know why my brain was thinking we're going to type in radioactive. So there's a whole bunch of commands you can actually use. These are all, you can see them here. You just type in atomic science. You can do atomic science /help, and it would be the same way. I'm going to show you all the commands. Now, you can do a series of commands. I've showed this off before. You can check your own radiation value. You can check radiation value of your other players. You can do it from the console or your own character. You can check your exposure level. Exposure will show you that rad value is what it will show you. So we'll do that. Right now I don't have an exposure value because there's no radiation nearby. You can then also do material, or mat, because I've got a shortcut set up for it. You can run a get command to get the radiation of the location, which you can actually go ahead and type that in. I'm going to do the prompt here so I can see exactly where we're standing. And we'll go ahead and run this off just to show that there is no actual radiation where I'm at. This does require you to tell it what dimension ID it is. I will kind of improve this over time, but honestly at the moment I don't anticipate anybody actually will use this. So we have to get, or if I can type it in right, if we run the get command, it'll go, hey, there's 0 units of radioactive material, but if we go in the set command, we can actually set the amount of radiation we want at that location. So we're going to be 101 units of radiation, and immediately you see at the top left the radiation actually is updated. and it will actually do show. And if we run the git command again, it'll tell me, yeah, you have that amount of radiation material at that location. And this will sit here, this will save and load to the world, and this is the only component that actually does save and load to the world for the radiation system. The actual rad values are calculated at runtime, and they are not saved, and they are discarded at the first available chance they get they're discarded. It is a very simplistic system. How it works at the moment is that it goes, okay, I have this amount of radiation value that I know I'm going to be able to transmit, and I'm going to decay that radiation over distance. It goes, okay, what's the max distance I can go before the radiation value hits 0? And then it goes, okay, if that value happens to be 5 blocks away from me, I'm going to grab all block locations within 5 blocks of me, and then I'm going to calculate the radiation value for them and set them in the world. Right now, we don't have a way for shielding to work at the moment. This will be implemented in the future. I just wanted to get the most simplistic code working out the way. And let me go ahead and show this code off, since that's what I usually do with these episodes. So we do have a thread for this. This is threaded, so this will be really good on performance. I haven't set a priority on it yet, so this will run at the same priority as the main world. I will come back in here later and set it to low priority, so if your main world is lagging it down, this will not cause it to lag down anymore, because what people don't really understand with how threads work is if you have multiple cores, it's cool, because then the thread will run per different core depending on how your operating system is designed. But if you only have like 1 or 2 cores to work with and they were being overburdened, and this thread somehow got onto the same core with your main thread, they will switch places with each other, so you can in theory actually still slow down the main thread using threaded systems. So coming through and setting a priority for that will work. Also with the set daemon, this means it'll just shut off when the game shuts off, which is very important with threading. Anyways, the actual bulk of this is how this works, is that when a chunk is actually added to the world, so when a new chunk loads up, it'll go ahead and queue this up for scanning. Only if there's actual data there, it'll queue it up. If a chunk is unloaded, it'll queue it up for removal. This will just run some really simple code that goes, okay, I knew I had radioactive material at this location, I need to remove the data so that way it's no longer in memory. And then it will also do a system where it goes, okay, I need to add new radioactive material. This is important because of how the system actually does work. As I explained previously, it goes, I have radioactive material here, it'll grab all the blocks within range and set the values. This is what this loop actually does here. This will go through and it'll grab all of the change queues that we have, and it'll go, I know what I need to change the value into. So if our previous value was 5 and our new value is 10, it will remove the previous value. So we'll go through and do that same check, we'll grab all the blocks within range, and it will remove that value of 5 off of them, and then it'll come through and it will add the new value of 10 in order to actually update it and get it working and everything else. So to go through that update location, and it really is a very simple equation. So it'll remove the value, it'll set the value. The remove call and set call look almost identical. Right now this is not the most optimized, but I'm not going to worry about optimization early until we get all the systems built up and cleaned up. And then I'll come back through here, because theoretically I can merge both of these loops together, but I'm not going to worry about that because that's going to cause complications in the design. But how it works, you get all 3 axes, X, Y, and Z, or actually it's X, Z, and Y is how I got it set up. And then it'll just go through and it'll calculate the values. Theoretically, what we would actually do if we want to add shielding into this, or decay as it goes through walls or plant matter and everything else, is just add a simple raid check into this method that will basically weaken it as it goes through the wall, depending on the different type of radiation. Theoretically, almost everything is going to block radiation because you've got 1 meter of material, and if you, for those that have never read a guide on making a nuclear bunker, basically a meter of soil will do a huge amount of stopping of radiation. It's actually quite impressive how little it takes to actually block radiation, and we kind of consider radiation as this big threat when in reality it's not actually as hard as people think it is to take care of, and that the mod is going to reflect on that. But simple setting of values and everything else, and it works really simple and does everything else, and it results in the value changing. Now as I actually move around, just take a look at this. Now the value in the counter doesn't actually update quickly. It's actually updated every, I think, second is when it's actually updated. I'm going to work on that, and I'm actually going to add some really cool features to it, including one rounding it off so you don't see all the zeros. But we'll, as you move around, you'll get different values. Now there is some rounding involved in this, and it's hard to see the rounding because we got the precision on here. But how the radiation is actually calculated is I grab the radiation at your feet, your midsection, and your head, and I average them out, which is the reason why we actually have a precision error here, where you got the dot and the numbers after it. But the actual values in the world are stored in whole numbers, and they're stored in 1/1000th of a rim. So at the value I'm standing at right now, it's actually 12,000 units of radiation is where it's actually at, and then that's converted into the actual rad you're exposed to, and it will be absorbed. As you do note though, as you can watch this, my rim value is not going up, even though I am wearing a radioactive suit. I take this off and get rid of that. I will not actually go up in radiation. That system has not been implemented yet, but it will be implemented here eventually. along with other things. For example, I still do need to implement making sure that entity items do transmit radiation on their own. I'm still not 100% sure how I'm going to handle this. At the moment, there's two possible paths. Either I just make the item transmit radiation actively over time, which will be really laggy if you too many items on the ground, or I switch it over to a system where it updates the exposure map just like the threaded system does, and updates the value, and as soon as it's removed from the world, it'll remove the value and everything else, which won't be too big of an issue if you really think about it. But I'll leave you guys here, and I'll come back with more content. That's about all I wanted to show off here, and I'll see you guys later.